Hello dear students, today we will discuss about acceleration due to gravity. As we know the term acceleration means change in velocity per unit time, that is called acceleration. But this term is acceleration due to gravity, okay. From name it is clear that this acceleration comes just because of the gravitational force, and this term is always denoted by small g. Okay, number of students ask about that what is the difference between capital G and small g. Okay, this is the very first difference, that capital G is a universal gravitational constant. Okay, that is a fixed number, and small g, this is a acceleration. Okay, acceleration due to gravity. So we have to discuss this term today, acceleration due to gravity. As I already told you, this is not any different thing. This is also a acceleration, but this acceleration because of the gravitational force, earth gravitational force, that's why it is called acceleration due to gravity. Okay, suppose that this is a one object. Okay, when an object is dropped from some height, a uniform acceleration is produced in it by the gravitational pull of the earth, and this acceleration is called acceleration due to gravity, because the body is freely falling body due to the gravitational force of the earth. Got it? And this value, this acceleration is denoted by small g, and this value at the surface of earth is 9.8 meter per second square. Okay, at the surface of earth, this is the value of small g. Got it my point? Okay, what does it mean that g equal to 9.8 meter per second square? It means that when a body is dropped freely, it falls with an acceleration of 9.8 meter per second square, and when a body is thrown vertically upwards, it undergoes a retardation of 9.8 meter per second square. In other terms, I can say in 1 second, a body increases its speed by 9.8 meter per second when any body dropped from h height or any height from the surface of earth. So this term is called acceleration due to gravity. Okay, there should be no confusion regarding that. What do you understand by acceleration due to gravity? Acceleration due to gravity is a acceleration which is produced by the earth's gravitational force. Okay, got it my point? Thank you. Okay, think about this concept, and we'll discuss another thing in later videos. Thank you. Wait, dear students, we can discuss the formula for acceleration due to gravity in this video also. Okay, now as we know that this is, suppose this is earth, okay, whose mass is capital M, okay, and this is a body which is falling towards earth, and suppose its mass is small m. We are supposing two things. Number one, this is earth whose mass is capital N, and an object which is moving towards earth center, which is called which is small m. So from gravitational force, we know that earth attract this object with a gravitational force, or you can say one thing, this object attracts earth with a force. Okay, that is Newton's gravitational force, and we know the value for that, which is F equal to g mm upon r square. What is m? M for mass of the earth, and small m, which is mass of that object. And what about this r? R means the distance between earth and that object. Okay, we know this formula, so this is a formula. Okay, now another thing, uh move to Newton's second law of motion, which we already discussed in second chapter. Okay, from there we know that if a body, suppose its mass is small m, so the force experienced by this object should be F equal to m into a. Am I right? Okay, so from here we can say F equal to m into a. What is m? This is mass of that object. What is A? The acceleration of that object. Okay, so I have already find out the force, gravitational force, and from Newton's second law of force, that is F equal to ma. Both should be same. So we can equalize the right hand side of this one. Okay, when we equalize the right hand side, then what we get, look at here, F g mm upon r square, it should be equal to m into a. Got it? So this small m can be cancelled out, because this is for the mass of the object. From here we can say this a equal to g m upon r square. We get this one. Okay, this is the acceleration of that object. This is that acceleration by which the object is moving towards the earth. And I already discussed that thing. That acceleration is called acceleration due to gravity. So I can write in place of a, that is g. Okay, so I can write in place of a g, small g. So it will be small g equal to capital G m upon r square. So this is very important formula. You have to memorize this formula. Okay, you can see here also it has written small g equal to g m upon r square. I think you got it. Okay, my point. So you have to prove the value of small g is g m upon r square. What do you understand by this m? This capital M for mass of the earth, and this capital G for gravitational constant. So you can observe one thing here. In this formula we do not have small m. It means that in this formula we do not have mass of an object. So it implies that the acceleration due to gravity doesn't depend on mass of an object. It always depend on mass of earth. Okay, this is very important thing, that whatever the object, whatever the mass of that object, the acceleration of that object does not change. It remain always constant for heavier object or lighter object, because the acceleration due to gravity does not depend on the mass of an object. Got it? So do this thing today, students. Okay, thank you very much.